Good evening, I am Mahalakshmi from the Department of AAML. So our project is a synthetic data generator system. So the main agenda in this PPT is first the introduction and statement of the problem like data scarcity, privacy and security and biased in data, and also purpose of the project and the proposed methodologies like data preposition, generative models, validation and the results and its implications, and also the literature review and the outcome and what is the project plan, conclusion and references. So the introduction is the high quality data sets are crucial for AIML development, and it has challenges like data scarcity, privacy concerns with sensitive information, and also it has ethical issues like surrounding data usage. And synthetic data provides a solution by mimicking real world data patterns, and also it supports industries like healthcare, finance and cybersecurity where data is sensitive and limited, and it also promotes responsible and privacy compliant information in AI and analytics. And the main statement of the problem is it has data scarcity like inefficient access to diverse data and also high cost and effect for data collection. And in privacy and security it has risk in handling sensitive information and also compliance with regulations like GDPR and CCPA. And it has imbalanced dataset leading to unfair AI model predictions, and also it has limited availability of high quality data for testing and training robust AI models. So the main scope of the project is first we have taken the pneumonia predictions, like for that it has generative synthetic data that mimics real world data sets while preserving statistical properties, and it also ensures data privacy by preventing re-identification of original data, and also provide users with customization options for data set attributes and structure. It enables validation of synthetic data through quality and quantity metrics, and it also supports various data formats like CSV, JSON, SQL for compatibility. And the proposed methodologies like for synthetic data generator system, for we have used data pre-processing where clean missing values and also handle outliers. It encodes categorical data, and for generative models we use GANs and VAEs for synthetic data generation. For validation we have used like statistical tests like Kolmogorov, Smirnov and also Jensen Shannon metrics. For customization, we have used fine-tuned synthetic data for domain specific requirements. And this is the architecture diagram or flow diagram for the synthetic data generator process. First, we have data set. We can train and test the data set by using the classifier, and it can also synthetic data by using data privacy, and also the data is very private, it has more privacy. This is the use case diagram like UML diagrams, where the data flow the data flow is like a random input is fed to the generator to create synthetic samples, while real images are sampled separately. Like a discrimination, like the discriminator evaluates both sets of samples, like calculating loss for real and synthetic data to improve realism. And also this is the design class diagram where first the scenario creation and data set generation is takes in place, and also it has reality in modeled into partial models like configured into parametric scenarios and simulated to produce synthetic data sets. And training and validation, for it has synthetic data sets are used to train the machine learning systems with a feedback loop for validation and adaptation to improve the model and scenarios. So this is the algorithm we have used in this data generation techniques like random sampling using uniform or normal distribution to create synthetic data mod points. For Gaussian distribution we have used it for generating continuous data with the defined mean and standard deviation. For noise injection we have used like Gaussian noise. It adds normally distributed noise to data for realistic variability. And salt and pepper noise is randomly adds extreme values like either maximum or minimum to simulate sensor or transmission errors. So like in for classification models we have used like decision tree, support vector machines and neural networks. Decision tree is a tree based algorithm used for classification and regression tasks. For support vector machines we have it's to find the hyperplane that best separates the data for binary classification. For neural networks, we have used like deep learning methods that are likely used to either generate or validate the synthetic data. So the hardware and software selection we have used like for the hardware requirements like processor Intel Core i7, the RAM minimum 16 GB, recommended 32 GB for larger data sets, and also the storage we have used is SSD with at least 512 GB. The GPU we have used like NVIDIA RTX 3060 or higher for AI based data generation. The network we have used like high speed internet for cloud based operations. The software requirements is we have used the Python programming language and cloud services like AWS, Google Cloud or Azure for scalable synthetic data generation. And the AML we have used like TensorFlow and PyTorch. The data privacy we have used is like differential privacy libraries, and for visualization we have used Seaborn, Potfly and also Matplotlib for data insights. uh, the implementation of the project is, first we have imported the Python libraries like OpenCV and PyTorch. The project includes Python scripts that can be used to detect and image files. From Google Drive, we are uploading the models and the data sets, so we can train the models using GANs. The Y model detects the obstacle or the object present in image. The obstacle is categorized into one of the various classes which are labeled in the dataset. It will display the bounding box as the output along with its class name. So this is the like code segments like the tabular data generated, where we have used data set data CSV file, and we can also get the like image with a high quality image, and also we can get how many images we need, and we can also save the image. So this is the main GUI code where we get the we can also add number of columns or number of rows we need, and what are the input, and we can also give the input for that columns and rows. And this is the main Kinter UI setup app. So this is the app where we can get we can get the data. So the output is, after browsing for the website, the following page will be shown first. The user needs to enter the data type and describe the image we want, and also enter the number of images we want. So as in this picture we can also see the what is the data type we have given, and also the describe what type of image we want, and also how many images we want. So, and also we can add the number of columns required that describes the image we want, and also enter the number of rows we want, like name, date of birth, phone number, and etc. So the expected results and implications are, so what can be accomplished is the high quality synthetic data sets replicating real world distributions, and also improved performance of AI models with balanced data, and ethical data usage while adhering to privacy regulations, and also supports innovation across domains without dependency on sensitive data. So these are the test cases, like first the user registration, user login, data scheme upload and everything. And so for the results we have get the data fidelity like 89%, and utility score we got 91%. For privacy preservation we got 94%, and the inference we have taken is high quality synthetic data, ensuring strong privacy while maintaining dataset utility. So the conclusion is that the synthetic data that has potential to transform AI by overcoming data scarcity and privacy issues, and it facilitates ethical and innovative practices in industries reliant on data. It addresses data privacy concern and promotes secure data sharing, and it also supports diverse industries by overcoming data scarcity challenges, and it accelerates AI innovation and model robustness through systematic data. And for future week we can also add enhancing data fidelity by using advanced generative models like GANs, VAE, etc. for and also improve statistical accuracy and feature correlation. And for strengthening privacy measures we can use the differential privacy and homomorphic encryptions, and federated learning for secure data generation. For AML integration we can use seamless pipeline, and also integration for model training, auto generated datasets for AI application. So this is the book references we have taken for this project, like synthetic data generation, evaluation methods and GANs. And thank you.